I'm Ben Rohrbaugh. I am the CEO and co-founder of Lantern UAS and the principal investigator for a research project done jointly with the BTI Institute here at the University of Houston. Drone technology and sensor technology are improving incredibly rapidly, and there are lots of applications that are a great technological fit, but where it hasn't been used yet because the regulatory environment is so complex and the security applications are so sensitive. And one of the biggest ones, the one we see is a largest opportunity, is in the security of cargo and conveyances at intermodal ports, and particularly at seaports. I mean, this is because at seaports, the volume of containers coming in is so enormous. There are about 50 million plus unique container entries into the United States every year. And each container is about the size and complexity, internal complexity of a moving truck for a single family household. So when you think about all of the stuff that's in these millions of different containers coming in and the complexity involved in searching them, the government is very limited, even using advanced technology and what it can do to determine exactly what's in the containers. Only about 5% of containers are searched after they arrive in the United States using X-rays and to some extent physical searches. At the same time, the government has very advanced in terms of the analytics it uses about what's inside the containers. They take advanced information, they take manifests, and they're able to make very smart decisions about which containers to apply those resources to. But even then, they're still very limited in the number of containers they can physically search. And so we believe that autonomous systems, and particularly aerial drones, can be a very significant additional tool to help authorities determine which containers are actually high risk, and to allow them to better use the manpower-intensive search resources and canine search resources that they have to make ports more secure and better secure the flow of cargo into the United States. And so what we did is we've partnered with the BTI Institute here at the University of Houston in order to develop specific systems, knitting together off-the-shelf sensors and off-the-shelf drones for the very, very specific uses that government operators in port contexts have. And these are pretty different than what you'd see in other public safety settings. A lot of other public safety settings for something like radiation detection, people are interested in keeping first responders safe, doing an overall map of, say, a disaster site. In a port context, authorities are interested in looking at a bunch of containers that are in the same places, the same times, and checking them for a very, very specific kind of threat. So we really needed to build custom systems for this kind of application. So working with BTI, we've created a controlled test environment. They have access here at the University of Houston to some really great industrial sites that are great sort of settings for us to test in the kind of environment we later see in a port context. So we have a controlled test site here on land that the university has. We are using things like radiation sources and other kinds of possible threats, and we're really interested in all kinds of threats that could be in a cargo container, but we're particularly focused on radiation sources, whether it's a nuclear material, possible dirty bomb. We're very interested in the presence of people or animals in containers for wildlife, human trafficking, human smuggling kinds of problems, and then we're also looking for indicators of contraband, especially narcotics, but also things like bulk cash, and maybe possibly, I guess, explosive traces or other kind of chemical concerns. And so what we're doing is testing a whole suite of different sensors and seeing what is the best fit. And what this does is it allows DHS and Customs and Border Protection operators to find out what works and what doesn't work and what's really promising without having to go out and spend weeks training their officers to become drone pilots who then maybe get moved to another port or going to have to procure all this equipment themselves and find the specific expertise to do it. We're able to do a lot of that research for them and advance these applications. So we've been very focused on radiation detection so far. We've built a system that it does passive radiation detection moving around a container. It's actually exceeded our expectations, which has been really exciting. Drones moving at about 1 meter per second have been able to detect very small sources through the walls of containers. And that really just speaks to how much the sensor capabilities have advanced even in the last 5 years. We're also looking at lots of different applications to identify things like possible narcotics smuggled in the linings of containers, traces on the vents, indications from the vapors that people might be in a container, all sorts of other things that hopefully will help farther narrow the number of containers in a port and help officers make better decisions about what they're searching for. The last thing we're doing is trying to integrate the information that drones can gather, which they can do quickly as they move around from container to container, taking pictures, capturing thermal imaging, and integrating that with the kind of information that would be useful for logistics, so that at the same time, port authorities will be able to do things like check the seals of containers, see if they've been tampered with, use that information to check against the manifest to make sure they're where they're supposed to be, while at the same time tracking where containers are for logistical purposes and benefits. So we think this is something that can be integrated with the automation that's already happening in ports, provide logistical benefits for the companies that are moving containers to specific places, and also really enhance the risk management that government authorities are doing.